So in this set of notes, we're going to learn one final way to solve a system of equations, and that's by using the method called substitution. And we're going to use that method to find the system, to find the solution to the system, which is the ordered pair where the two lines are going to intersect in the coordinate plane. So if you remember, we can already solve a system of equations by graphing and seeing where the two lines intersect, and we can already solve by elimination, which is when we add or subtract our equations together in order to get one of our variables to eliminate. Substitution is going to involve substituting. And remember the bag activity from earlier in the year, and when you substitute, you need to use parentheses. That's going to be super important as we go through the process of substitution. There are some steps to substitution. The first one is going to be to isolate any variable. You can either isolate x or y from either equation, and you can do whichever is easiest. Things to look for that are going to make isolating easy is if there's a coefficient of 1 or -1, if 1's not available. And we're going to talk about divisibility. And so what that means is if you're going to have to divide to get a variable isolated, you're going to want to make sure everything is divisible if possible. After we've isolated any variable, we're then going to substitute, notice this is written in parentheses, the expression into the other equation. This is important because you might be isolating from the first equation, you might be isolating from the second equation, but when it's time to substitute, you're going to go into the other equation, whichever one you haven't used yet. Then you're going to solve your new equation with one variable. So your new equation should only have one variable, either x or y, involved. And then you're going to plug this value into the isolated equation to find the second half of the ordered pair. Because remember, our solution to a system is always an ordered pair x, y. So let's see this in action. So on example 1, I have my system of equations, y equals 3x plus 2 and x plus 2y equals 11. So again, I could graph this and see where the two lines intersect. I could eliminate, but in order to eliminate, I'd have to rearrange my top equation so everything was stacked nicely on top of each other. I also might have to multiply. But in this case, I look at my steps. So step 1 says isolate any variable. Well, here I notice that y is already isolated. And so what this really means is that everywhere I see a y, hey, I see a y right here, I can replace it with 3x plus 2 because that's what y is equivalent to. So on this second equation, I can rewrite this. Now imagine you had to rewrite this, but that the variable y didn't exist in the alphabet. So instead of writing y, what we're going to have to write is what y is equal to, which is 3x plus 2. So this is what this would look like. Here's my bottom equation, x plus 2 times y, but oh wait, I can't use y, so I'm going to have to use 3x plus 2. And I have to put that inside parentheses because 2 is multiplying everything that y is, which means that 2 needs to multiply both the 3x and the 2. So I need to have this in parentheses in order to distribute. I substituted in using parentheses, and now I'm going to solve my one equation that only has the variable x. So to solve this equation, I'm first going to distribute. So I'm going to get x plus 6x plus 4 equals 11. Then I'm going to combine, so I'm going to get 7x plus 4 equals 11. Then I would subtract 4 from both sides. So you can see now I'm just solving a traditional single variable equation. And so my new equation would say 7x equals 7. Then I would divide both sides by 7 to get x equals 1. But remember, this is only half of my solution because my solution is an ordered pair. So I have 1 comma, and I'm still looking for my y. So now in order to find my y value, I'm going to go back, according to this, I'm going to go back to my isolated equation, which says y equals 3 times x plus 2. Well, now I know that x is 1, and so that means that y is going to equal 3 times 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5. And so what this means is that y equals 5. And so my solution to the system is 1, 5. And what this would mean is that if I were to graph these two equations and look at where they intersected, they would intersect at the point 1, 5. So at this point, I want you to pause the video and try example 2. The thing that I want to point out to you is that x is already isolated, and x equals -6 plus 2y. And so what this means is that everywhere you see an x in the second equation, which is here, you can replace that with negative 6 plus 2y. Pause the video, press play when you're ready to check your answer. So here I have 4 times x, but instead of writing x, I wrote negative 6 plus 2y because that's what x is equal to. And I rewrote the rest of the equation as well, so plus 6y equals 4. I then distributed 4, so negative 24 plus 8y plus 6y equals 4. 8y and 6y combine to get 14y, so I've got negative 24 plus 14y equals 4. I then added 24 to both sides to get 14y equals 28, and then divided by 14 to get y equals 2. But remember, that's only half of my solution. So to get the x-coordinate of my solution, I went back to where x was isolated, and I replaced y with 2. And so that said x equals negative 6 plus 2 times 2. 2 times 2 is 4, and 4 plus negative 6 is negative 2. And so my point of intersection would be negative 2, 2. Let's look at example 3. So according to step 1, my first step is to isolate any variable. So what I notice here is that in order to get y isolated, all I would need to do to both sides of my equation is subtract 2x. So I'm going to go ahead and do that. So if I have y plus 2x equals 5, if I minus 2x from both sides, that means y would equal 5 minus 2x. Now what this says is that everywhere I see a y, and I see one here, I can replace it with 5 minus 2x. So I'm going to rewrite this equation, but instead of writing y, I'm going to write 5 minus 2x in its place. I'm substituting that in. So I've got 3x plus 5 minus 2x equals 10. Now I always use parentheses just to be safe, but in this case what I'm really doing is I'm distributing an imaginary 1, and since anything times 1 is itself, I can just get rid of those parentheses. So I'm going to get 3x plus 5 minus 2x equals 10. Now I'm going to combine like terms, 3x and negative 2x, don't forget that sign, combine to get 1x plus 5 equals 10, and then I can subtract 5 from both sides, and so what this would mean is that 1x, which is just x, this should have said 10, I rewrote that by accident, and so this would mean that x equals 5. And I almost circled my answer, but I'm not ready to circle it yet because I don't have a complete answer. Right now, all I have is the x-coordinate of my ordered pair. Now to find the missing y-coordinate, I could go back to the original system, but what I'm going to do is I'm going to go to where y was isolated. And so this says that in order to find y, I should do 5 minus 2 times whatever x was. And I now know that x was 5. So to find y, I'm going to do y equals 5 minus 2 times 5, which would be 5 minus 10, which means that y would equal negative 5. And so that means my point of intersection, my solution is 5, negative 5. So at this point, you're going to go ahead and pause the video, try example 4. Start by thinking about which of your 4 variables, x, y, are going to be the easiest to isolate. Isolate that variable first, substitute it in, solve your new equation, and don't forget to find the second half of your ordered pair. Pause the video, press play when you're ready to check your answer. So in this example, I noticed that in order to get this x isolated, all I had to do was add y to the other side. And so that's what I did over here. I isolated my top x. Both of the x's had a coefficient of 1. I just happened to see this one first. But either way, x is going to be your easiest variable to isolate. So x equals 3 plus y. What this meant is that anywhere I saw an x in my other equation, I could replace that with 3 plus y. So that's exactly what I did here. I rewrote this equation as 3 plus y plus 2y equals negative 6. Now since this is really distributing a 1, anything times 1 is itself, that's just going to be 3 plus y. I then combined y and 2y to get 3y, and so I have 3 plus 3y equals negative 6. I then subtracted 3 from both sides, and so 3y would equal negative 9, because a negative 6 minus 3 would be negative 9. I divided both sides by 3 to get y equals negative 3, but that was only half of my ordered pair. To find the x-coordinate, I went back to where x was isolated and knew that to find x, I would just have to do 3 plus whatever y was, and now I know that y is negative 3. And 3 plus negative 3 is 0. And so my solution is 0, negative 3. So for examples 5 through 9, that should be example 9, you're going to pause the video and press play when you're ready to check your answers. You want to make sure you start by isolating whichever variable is going to be the easiest to isolate if there isn't one isolated already. When you're ready to check your answers, press play. So on example 5, I isolated y from the first equation because it was the only variable with a coefficient of 1. And to do that, I subtracted 3x from both sides. And so what this said is that everywhere I saw a y, which I saw in the second equation, I could replace it with negative 7 minus 3x. And so that's what I did. And so what that equation said was negative 2x plus 4 times negative 7 minus 3x equals 0. Then I distributed 4 to get negative 2x plus negative 28 minus 12x equals 0. Negative 2x and negative 12x combine to get negative 14x minus 28 equals 0. Add 28 to both sides and divide by negative 14 to get x equals negative 2. Then I went back to where y was isolated to replace x with negative 2. Now here it's a negative 3 times a negative 2, which gets a positive 6. And so then negative 7 plus 1 is negative 1 for a final answer of negative 2, 1. On example 6, I knew that y was already isolated, and so this said everywhere I see a y, which I see one right here, I can replace that with 2x minus 3. So I replaced y in the second equation with 2x minus 3 and distributed 3 to get x plus 6x minus 9 equals 5. X plus 6x is 7x minus 9 equals 5. Then I added 9 and divided by 7 to get x equals 2. Then I had y equals, where y was isolated, 2 times x, but now I know that x is 2. 2 times 2 is 4, and 4 minus 3 is 1, and so that meant my y value is 1 for a solution of 2, 1. On example 7, the variable I chose to isolate was y in the top equation because this was the only variable that had a coefficient of either 1 or negative 1. Now to get y by itself, it was a two-step process. I first had to add 5x to both sides, but then I still had a negative in front of the y, so then I still had to divide by negative 1. And so that would be negative 12 and negative 5x. And so now, everywhere I saw a y in the second equation, I could replace that with negative 12 minus 5x. So the first thing on this example is to make sure that your first variable is isolated correctly. So then I had 3x minus 5 times y, which was negative 12 minus 5x equals 4. A negative 5 times a negative 12 is a positive 60, and a negative 5 times a negative 5x was a positive 25x. Make sure your signs are correct at this point. 3x and 25x combine to get 28x plus 60 equals 4, and then I subtracted 60 from both sides to get negative 56, and divided by 28 to get x equals negative 2. I then went back to where y was isolated to get negative 12 minus 5 times 2. 5 times 2 is 10, and negative, I just realized I made an error, negative 12 minus 10 would actually be negative 22. And so this means that my solution should have been negative 2, negative 22. All because I forgot that negative sign. On example 8, I chose to isolate the y from my top equation by subtracting 2x from both sides. This says that everywhere I see a y, which I saw here, I could replace this with negative 6 minus 2x. One key on this problem is that it says 4x minus, and then we have to subtract y. This is where your parentheses are really important. Notice my y value, which is negative 6 minus 2x, is inside the parentheses, which means I'm distributing this negative sign through, which is why I have a positive 6 and a positive 2x, because the opposite of negative 6 is positive 6, and the opposite of negative 2 is positive 2. 4x and 2x combine to get 6x plus 6 equals negative 18. Subtracting 6 from both sides, I got 6x equals negative 24, and then divide by 6 to get x equals negative 4. So then I changed x to negative 4, and what I saw was that I had a negative 2 and a negative 4, so I made those two negative signs a positive, and so then I had negative 6 plus 8 to get a positive 2. So my ordered pair was negative 4, 2 as my solution. On example, what's really 9, although it says example 8, even though I had a fraction, it was actually pretty simple to get y by itself by adding 1/2 x to both sides. And so everywhere I see a y here, I can replace y with negative 1 plus 1/2 x. So I had negative 2x plus 8 times y, but I'm using negative 1 plus 1/2 x for y, equals negative 7. 8 times negative 1 is negative 8, and 8 times 1/2 x is 4x. Negative 2x and 4x combine to get 2x, minus 8 equals negative 7. I then added 8 to both sides, and divided by 2 to get an x coordinate of 1/2. I then took this value and plugged it into where y was isolated, and so here I'm going to replace x with 1/2. 1/2 times 1/2 is 1/4, and then I was adding 1/4 to -1. So I did this off to the side, and I did -1/1 plus 1/4, and I made a common denominator of 4. And so -4/4 plus 1/4 would be -3/4 for a final answer of positive 1/2, -3/4. So on this word problem, we're deciding between 2 gym memberships, and the costs are outlined in the table below. For Planet Fitness, you have to pay a sign-up fee of $10 and then $21.95 a month. For Workout World, you do not have to pay a sign-up fee, but you're paying $22.45 a month. So it asks us to create a system of equations to show the cost of both gyms based on the number of months. So maybe we use x to represent the number of months and y to represent our total cost. And so that means for Planet Fitness, our total cost would be $10 plus $21.95x, and for Workout World, it would be total cost is just $22.45x. Now to solve this system to determine when the cost will be the same for both gyms, what I can do is where I see a y, I can replace it with y's value. So here this says everywhere I see a y, I see one here, I can replace it with 10 plus 21.95x. So essentially what I'm going to create is this equation with variables on both sides. 10 plus 21.95x equals 22.45x. And these are the type of equations that we were solving in Unit 2. I would then subtract 21.95x from both sides to get 10 equals 0.5x, and then I would divide both sides by 0.5. Now if I didn't have a calculator, one kind of interesting thing here is that 10 divided by 0.5 is the same as 10 divided by 1/2, and to divide by fractions, I can multiply by the reciprocal, and so this would mean that x equals 20. Now if x were to equal 20, I can then plug that back in to where my x is to figure out what my cost would need to be, and so I could do y equals 22.45 times 20, and that would be 449. And so that means my solution to this system is 20,449. And so then the last part says explain in complete sentences what the solution means, and it says be sure to talk about both variables x and y. So I know that x is my number of months, and I know that y is my total cost. And so what this means is that at 20 months, the cost for both gyms will be $449. Make sure you're saying that they're just the same, which is true, but specifically what that cost is of $449. So in this example, you are comparing food cooperatives that are either clubs or retail stores, and to see when their costs will be the same. So we know that at a club, the club fee is $20, and then it's $15 per week. And at the store, we have no fee, but a cost of $17.50 per week. So you're going to create your system of equations to show the cost of both types of businesses based on the number of weeks. You're going to solve your system to determine when the number of weeks it would be for the two businesses to be equal, and then you're going to explain in complete sentences what your solution means. Pause the video, press play when you're ready to check your answers.